Hello, this is Thales' Disciple continuing a series of videos on dynamical systems. This time, we'll see how understanding circle rotations, which were the subject of the last video, can help us understand another system, which I'm calling Funhouse reflections. Now, this doesn't mean there are going to be tilted floors or clowns or... Wait, you know what? Let's have a clown. So suppose there's a clown in a room that's shaped like a cylinder, and the wall is a perfect mirror. When the clown looks at the wall, what does he see? Well, since the walls are curved, that depends on where he's standing. If he's close to the wall, then it will act almost like a normal flat mirror, and he just sees himself normally. But as he backs away towards the middle of the room, the reflected image he sees will grow. In fact, when he stands right in the center, he sees nothing but himself in all directions. Here are two pictures of an actual cylindrical mirror, although not one that completely encircles anything, to show how an object is seen differently by the viewer, depending on where it is placed. To understand what's happening, we have to think about how light is reflected in the mirror. First, take the simpler situation where the mirror is flat. In this case, when the light reaches the mirror, its path is transformed according to the old law, the angle of incidence equals the angle of reflection. If we go back to the curved mirror, what happens when the light reaches a point of the mirror? Well, it behaves according to the same law, using the tangent line to measure angles. So let's suppose the clown has his miniature elephant sitting in the middle of the cylindrical room, and he is standing elsewhere, looking through a narrow tube. In what directions can he face and still see the elephant? Let's look at what paths light can follow in this room. Starting at one point, the light proceeds towards the wall, strikes it, and is reflected. Now, since the two pieces of its path make the same angle with the tangent line at that point, they also make the same angle with the diameter of the circle through that point. This is using the symmetry of the circle itself. So the light proceeds on its new course until it reaches the wall again, and is reflected. And again. But notice what is happening. Each time the light reaches the wall, the new angle is the same as the old one. This again is due to the symmetry of the circle. The whole picture is simply rotated. So the pattern of points the light reaches on the wall can be described by a rotation around the outside of the circle. And we know what happens with circle rotations from the last video. One possibility is that the light follows a periodic sequence of points around the room, tracing out the sides of a regular polygon. The other is that the points at which the light hits the wall fill up the wall over time. We saw that that was the second possibility last time. But this doesn't mean that the light passes through every point of the room on its way. Each time it crosses the room, there is a certain point where it is closest to the center. And this distance never changes on successive crossings. The path always stays tangent to an inner circle. Thus, the path of light fills up the ring, which is called an annulus, between the wall and this inner circle. I wish I could show this to you really, but I don't have a lab. So, in what directions can the clown see the elephant in the room? Well, if the elephant were a point, and the tube only let the clown see in a perfect line, he'd either have to be looking right at the elephant, or directly at the wall. In any other direction, the light that enters the tube will always miss the center. This study of light bouncing around a cylindrical room is an example of a billiard system. Over the next few videos, we'll look at billiards inside of other shapes.